Hi, welcome to LiPaper Sendirian Berhad. For the introduction, since lignin peroxidase had been found very helpful in the colorization process in biorefinery, cosmetology, dermatology, and also in textile industry, LiPaper Sendirian Berhad choose white rot fungi, which is phenyroshade chrysosporin sp, to produce an enzyme lignin peroxidase in an industrial scale. This enzyme will use in the biopulping and biobleaching process of paper production. Therefore, we focus on designing bioreactor for the production of lignin peroxidase by using phenyroshade chrysosporin. This is our company organization chart. Kuek Sue as Chief Executive Officer, Muhammad Ridwan as Plant Manager, Dia Nazira binti Roma as Design Engineer, and Aina Zafira binti Anwar as Design Engineer also. Teh Chin Wen as Process Manager. Same goes to the Noraini binti Hamdin as Process Manager, Jilin Suailam as Safety Manager, and Bella Halida and Siti Aisyah as Quality Assurance Manager. For the inoculum, we have phenyroshade chrysosporin sp, polyurethane foam, and also condition. For the media, we have glucose, yeast, polypeptone, twin acti, trace element solution, diammonium tartrate, magnesium sulfate, calcium chloride, iron 2 sulfate, phosphoric acid, and also vitamin solution. For the fermentation in fermenter, we have condition, design fermenter or bioreactor, and the last one is sterilization. Condition: we need 34 until 37 degrees Celsius, 7 days, and 4.2 until 6.2 pH value. This is the design fermenter and bioreactor. This is the diagram of impeller. We have top view, front view, and the side view. Move to the sterilization. A bioreactor must be sterilized before inoculation because contamination is common cause of process failure. For large bioreactor, in situ sterilization is the components should be able to sterilize independently during fermentation if required. The aeration and exhaust group must also be sterilized. The filter are rated for removing partial down to 0.22 micrometer or even 0.1 micrometer. Often the gas stream require 2 filter cartridge in series, with the first serving to protect the second filter. So, advantages stir tank bioreactor. First one, the efficient transfer of gas to growing cells, which keeps the growth of cells in healthy limits. Second, easily available, which make them commercially viable products. Third, the operating conditions are flexible. Fourth, stirring ensures good mixing of the contents. This is our overall process flow diagram. Specifications for unit procedure and its operation data. Blending storage 1. Nutrient 1 for charge 1, nutrient 2 for charge 2, followed by agitation process. For charge 1 and charge 2, flow rate is 600 L per H. Nutrient media in transfer out with the same flow rate. Proceed with CIP, clean in place. This is the list of composition of nutrient 1, and this is the ratio of nutrient 1 and water, which is 1:1. The temperature is 37 degrees Celsius and 7 value for pH. Heat sterilization. A bioreactor must heat before inoculation to prevent contamination. It will undergo in situ sterilization with given pressure and temperature. Shake flask. For the input, we have nutrient 2, water 2, oxygen, and phaneroshade chrysosporium. For the output, we have culture and vent. Input. In charge 1, they have nutrient 2. In charge 2, we have water 2. And in charge 3, we have phaneroshade chrysosporium, followed by agitation and fermentation process. This is the stoichiometry equation in this process. Output. We have transfer out and venting process. Next, our main component in this process is batch stir tank bioreactor. We have 3 input in here, which is phaneroshade chrysosporium, media, and oxygen. For flow rate of each stream for this process is same in transfer 1, transfer 2, and transfer out, which is 600 liter per hour, but different in process time. It is also followed by fermentation, CIP, and SIP. There are 2 conditions occur in this bioreactor, which is primary metabolite and secondary metabolite. Primary metabolite consists of lag phase, exponential phase, and stationary phase. Blending storage 2. Nutrient 3 for charge 1, water for charge 2, and agitation process. The flow rate for charge 1 and charge 2 is 600 liter per H. Nutrient media in the transfer out with flow rate 600 liter per H also proceed with CIP. This is the list of nutrient and the ratio of nutrient 3 and water is 1:1. The temperature is 37 degrees Celsius and for the pH is 7. We are using the second batch stirred bioreactor that include same media, phaneroshade chrysosporium, and also oxygen. For secondary metabolites, the production will occur when the growth of cells start to slow. By adding some nutrient, it will reduce amount of nitrogen source and it will create stress to the cell. Same goes to primary metabolite. Volumetric flow rate for transfer 1, transfer 2, and transfer out still the same, which is 600 liter per hour but different process time, followed by fermentation, agitation, CIP, and SIP. Next unit procedure is centrifuge. For solid removal, 1 micron of diameter limiting solid particles, 98% of removal biomass and malt agar, 20,000 for centrifugal force, 3 hours for centrifugation time, and 500 gram per liter for solid concentration in solid stream. For microfiltration, this is the list of rejection coefficient and the process time is 2.5 hours. 15.45 degrees Celsius as final temperature, chill water as cooling agent, and also 5% of product denaturation data. For membrane, involve physical separation that depend on pressure that removes the soft solids using polyvinylidene difluoride membrane with pore size of 0.450 micrometer. The configuration of the membrane used is spiral wound. Advantages: spiral wound, balanced durability, high membrane area per unit, and lower cost. PVDF membrane, it is suitable for biological, environmental, and compatible with sterilization method. We will move to the blending tank for product from microfiltration. Total duration in this process, which is transfer in, agitation, transfer out, and CIP, it took about 3.42 hours at 25 degrees Celsius. For input and output stream, it consists of biomass, calcium chloride, diammonium tartrate, enzyme, glucose, impurities, iron sulfate, magnesium sulfate, malt agar, pheneroche chrysosporium, phosphoric acid, twin acti, vitamin solution, water, and yeast. For the next unit procedure, which is ultrafiltration, this equipment consists of membrane specification, polysulfur membrane, molecular weight cutoff 10 kilodalton. This is the list of rejection coefficient and the product denaturation. For the filtration time, it will take around 2 hours for this process. For input stream, in storage and blending tank, the composition is still the same. And in output stream, the filtrate will be removed with a small amount of fluoride. Meanwhile, the remaining composition will be removed in product output stream, but in this different flow rate. We will move to another blending storage tank. The total duration for this transfer in, transfer out is 2.28 hours at 25 degrees Celsius. This is the component in input and output stream. The enzyme produced is lignin peroxidase. Scheduling analysis. Batch cycle show that we obtain a same amount of maximum batches per year and actual batches per year, which is 33. In here, we have 12 equipment schedule process that include start time, end time, busy time, idle time, occupied time, unoccupied time, and wait time. For more easier observation, this data was transferred into the graph. Idle time and unoccupied time is the highest data for each equipment. Next, for scheduling analysis, batch time, cycle time, AOT available, and AOT utilized are obtained during the entire process. Last one, we also perform a Gantt chart that illustrates a project schedule for this entire production. Now, we will present about economic analysis. Raw materials cost. Total annual cost for this is $3,275,767 US. In our cost material, phenol sheet SP is the most expensive. The most cheaper material is the water since it is easy to get. As written, it is our total cost for raw material. Right now, we will move to data of equipment costs. Total for all 11 equipment cost is $7,955,000 US. Then, this is the data for our maintenance cost. Total for maintenance cost already divided in kilogram per MP, batch and year. Now, let's take a look at labor cost data. The annual cost is $1,851,740 US. This is our data for payback time. In this production, payback time will take around 3.58 years. Environmental and impact analysis. For emission waste, carbon dioxide are released during the lignin peroxidase production. Mass composition of carbon dioxide at first emission is higher compared to second emission, which is 0.05% and 0.04%. In addition, 781.03 is the amount for emission contribute. In here, we provide the solution for emission release and for the waste treatment.